class 9th. We will be doing the problem based on logarithms. We have done a lot of work on logarithm already, and I'm going to try to solve some more sums based on from your book so that you understand it more. First question which I'm going to try is, he says simplify. Like it is log 8 into log 9 upon log 27. Now please understand, just look at the question. Log 8 into log 9 does not mean log 8 plus log 9. If it is log A into B, then I can write it as log A plus log B. Or log A plus log B can be converted into multiplication, but not like this. Not log A into log B. Log A into log B is not equal to log A plus log B. This is one thing you have to distinguish. The other thing is, it is log 9 here, it is log 27 here. So we can convert 9 as well as 27 as powers of 3. As powers of 3, because log 9 is 3 to the power 2. Log 27 can be written as 3 to the power 3. The other thing is that there are no bases given here. When no bases are given in the logarithms, then we consider them as common logarithm, that is to the base 10. So let us not bother about the bases because they are common, that is log to the base 10. I'm not going to write it because it is already not written, so I need not to complicate it more by writing. It is log 8, I can write 2 to the power 3. Log 9, he says simplify, I must simplify 3 to the power 2 and log 3 to the power 3. Log 2 to the power 3, log 3 to the power 2, log 3 to the power 3. Next step, log 3 log 2 into 2 log 3 upon 3 log 3. Power law. The power can be brought as multiple. 3 log 2, 2 log 3 and 3 log 3. Now you can see here log 3 can be cancelled, 3 and 3 can be cancelled. What is left is 2 log 2. 2 is left from here, log 2 from here. So it can be written as 2 log 2. I can take 2 as the power, log 2 to the power 2, or it could be written as log 4. This is the most simplified form from here. We started with log 8 into log 9 upon log 27. From this we were able to simplify it to log 4. We could convert it into log 4 by writing log 8 as 2 to the power 3, 9 as 3 to the power 2, 27 as 3 to the power 3, and then we brought the power in the beginning and cancel or cut whatever was there from numerator and denominator, and whatever was left is written the most simplified form. Like we have got 2 log 2, then I am writing 2 log 2 as log 2 to the power 2. Now let us see question number 2. It is log 9 minus log 3 upon log 27. Now it is log A minus log B. Log A minus log B. Log A minus log B can be written as log A upon B. Quotient law. Log 9 upon 3 I can write. Log A upon B upon log 27. 27 is again 3 to the power 3. It will be what? 3 3s are 9. So log 3 upon 3 log 3. In the numerator I have got log 3. In the denominator I have got log 3 log 3, log 3 log 3 will cancel, I'll get 1 upon 3 as the answer. I will get 1 upon 3 as the answer. I will get 1 upon 3 as the answer. Now let us see this third question, which says evaluate. Evaluate. What has to be evaluated? This given statement. 2 plus half log 10 to the power minus 3. Whenever a mixture is given, like this is a number and then logarithm is given, convert this into logarithm as well if we want to evaluate or simplify, because there is no base given here. There is no base given. That means common base is there, common logarithm is there, that is base 10. So log 2 can be written as log 100. Log 100 to the base 2, log 100 to the base 10 is equal to 2. 10 to the power 2 is 100. So log 100 plus half into minus 3. I brought this power in the beginning. This power has been brought as the multiple, half into minus 3, and this is log 10. Now it is log 100 is obvious, even you didn't need to do this. You could leave it as 2 only because we don't need to. 2 plus, this will come what? Minus 3 upon 2, and log 10 is 1. Log 10 is 1. So it is 2 minus 3 upon 2, that is 4 minus 3 upon 2, that is 1 upon 2. So we have evaluated the value like this, but generally when we are evaluating, we try to convert into logarithmic form. Here we could do it without converting to the logarithmic form, because we didn't need to do that. Finally we realized, first I did that again we had to write it as 2, so there was no point converting. So that is why I left it as 2 and simplified this, and from this I got minus 3 upon 2, 2 minus 3 upon 2 is equal to 4 minus 3, 1. Now let us look question number 4, which is 2 log 5 plus 3 log 2, log 3 plus 3 log 2 minus half log 36 minus 2 log 10. Everywhere we have the multiple. Everywhere except leaving log 3, I have multiple 2 here. 3 is the multiple, half is the multiple, 2 is the multiple. I'll take them as the powers, because I have to simplify, I have to join all the things together, because I want to evaluate the value of this given statement, mathematical statement. Log 5 to the power 2 plus log 3 plus log 2 to the power 3 minus log 36 to the power half minus log 10 to the power 2. Now it will become, whatever is the addition will convert into multiplication. This plus this plus this will convert into multiplication. That is log 5 to the power 2 into 3 into 2 to the power 3. This is addition will convert into multiplication. This both are minus. Minus will convert into division. 36 to the power half means 6. And 10 to the power 2 means 100. 36 to the power half you can write here, so that no confusion. 36 to the power half and 10 to the power 2. In the next step we will remove all this. Like it will become 25 into 3 into 8. 5 to the power 2 is 25, 3 is 3, 2 to the power 3 is 8 upon 6 into 100. So now let us cancel whatever we can cancel. 25, 4 is 100, 3 2s are 6, 4 2s are 8. So you are left with log 1 actually. Log 1. And there is no base, that means it is to the common logarithm. Base 10 is there, and log 1 is always 0, whatever may be the base also. Whatever may be the base, log 1 is always going to be 0, because any non-zero risen to power 0 is 1, and we can take only logarithm of positive numbers. So any base, even if any base is there except 10, even then it is going to be 1. Log 1 is going to be 0. So we were able to evaluate this equal to log 1, and log 1 is 0. Now let us see the fifth question on the same base, exactly same basis we will be doing question number 5. In question number 5 I have log 2 plus 16 log 16 upon 15 plus 2 log 25 upon 24 plus 7 log 81 upon 80. Now what are we going to do? We are going to put the multiples as powers. That is log 2 plus log 16 upon 15 to the power 16 plus log 25 upon 24 to the power 2 plus log 81 upon 80 to the power 7. Now let us change them to basic factors, prime factors. It will help you later. Log 2 plus log 16 means 2 to the power 4. 2 to the 4, 2 to the 8, 2 to the 16. I've converted. 15 can be written as 3 into 5 plus log, it is 5 to the power 2. 24 is 8 3s are 24. 2 to the power 3 into 3. 8 3s are 24 to the power 2 plus log 81 means 3 to the power 4, and 80 will be 16 5s are 80. 16 is 2 to the power 4 into 5 to the power 7. You see, we are trying to convert everything in 2. 2 is here, prime number, 2 is here somewhere. 2s are here. Then 3 is here, 3 is here, and 3 is here. 5 is here, 5 is here, 5 is here. So we are converting everything into the power of, and 2 was here. So 2, 3, 5. Now what is going to happen is log 2 plus log, it is 16, it is power 16 here. So 2 to the power 4 to the power 16, that means 2 to the power 64. 2 to the power 64. Now 3 to the power 16, 5 to the power 16. Similarly, plus log, it will be 5 to the power 4, 5 to the power 12 it is, not 4, it is 12. 12 2s are 24, and 2 to the power 12 3s are 36, and 3 to the power 12. Because it was 12, not 2. After that, it is power 7, so it is log 3 to the power 28 upon 2 to the power 4 7s are 28 into 5 to the power 7. All our additions will convert into multiplication. Log A plus log B plus log C plus log D. So we can convert everything into multiplication. That will become log 2 into 2 to the power 64 into 5 to the power 24 into 3 to the power 28 upon, here there is nothing, here it is 3 to the power 16 into 5 to the power 16, 2 to the power 36, 3 to the power 12, 2 to the power 28, and 5 to the power 7. Okay. Now let us calculate what will we get. 2 has got power 1, 2 has got power 64. So it is 2 to the power 65 in the numerator. Let us see in the denominator. 2 is 36, 2 to the power 36, 2 to the power 28. It will be 64. 8, 6, 14, yes. 2 to the power 64 into. Let's see what is the power of 3. 3 has got power 28 here. And what is the power of 3? 16 and 12. 16 and 12 is 28. So 3 has got power 28. Now let us see what is the power of 5 here. What is the power of 5 here? 5 has got power 24 here. And 5 has got power 16 here. And 5 has got power 7 here. 16, 7, 23. 5 to the power 23. 3 to the power 28, 3 to the power 28 will cancel. It is 2 to the power 65 minus 2 to the power 64. That will be only 1 power, 1 2 will be left here and 1 5 will be left here. So log 2 into 5. Because it is 2 to the power 65, it is 2 to the power 64. 64 2's will cancel, only 1 2 will remain. Here 5 to the power 24, 5 to the power 23. So 23 5's will cancel, only 1 5 will remain. And log 10 is 1. Log 10 is 1. The value of log 10 is 1. It's very simple, just calculation is there, to the powers are there. And then you have to calculate correctly the powers. Then apply the law of the logarithm. Log a plus log b plus log c plus log d is log a into b into c into d, and then cancel the powers, whatever you can cancel, and finally we got log 2 into 5 is left, which is log 10, and the log 10 is 1. Now let us see question number 6 after this. In question number 6 I have express a single logarithm. Express a single logarithm is 2 log 5. He has given the base 10 here. He has mentioned the base 10, so we will write the base 10 minus log 2 to the base 10 plus 3 log 4 to the base 10 plus 1. Plus 1. So it will be log 5 to the power 2 to the base 10 minus log 2 to the base 10 plus log 4 to the power 3 to the base 10 plus log 10 to the base 10. Because I have to convert everything into logarithm to combine them, because he wants to evaluate, and for evaluation we have to simplify. So it will become what? It is plus, it is plus, it is plus. They will be added. That will be log 5 to the power 2, 4 to the power 3 and 10 upon 2. Upon 2. Log A plus log B plus log C will be log A into B into C, and this was subtraction. So subtraction will come as division. Now let us see what we can get. Log 25, actually 125 you can write, because 5 will 2 5 are 10, so 5 to the power 3 is 125 into 4 4 is 16, 4 is 64, and multiply 125 into 64, probably it will become log 8000. If you multiply this, it will come 8000. What was it? 25 into 64. 13 4s are 25 4s are 100. 10 will be carried. 25 6 are 150 plus 10 160 into 5 into 5 again. So how much will it be? 1600. It should be actually 25 4s are 100 and 25, 6, 150, 160, 1600 into 5, that will be, yes, 8000, log 8000 to the base 10. That will be the answer. That is the answer. You have to just multiply 125 into 64, that will come out to be 8000, log 8000 to the base 10. So that is the answer. Now let us see question number 7. I have half log 9 plus 2 log 3 minus log 6 plus log 2 minus 2 minus 2. So half log 9 plus 2 log 3 minus log 6 plus log 2 minus 2. So it is no base is given, that means again the base is 10 to the common base, and 2 can be written as log 100. So it will be log 9 to the power half plus log 3 to the power 2, because power goes as the multiple goes as the power, minus log 6 plus log 2 and minus log 100. Log 100 is 2 to the base 10, because there is no base given, that means common logarithm is there. So now it is log, let us apply the law, A, B, C. So the multiplication will, addition will convert into multiplication. 9 to the power half is 3, 3 to the power 2 is 9 into 2. And what is minus will come down, that is 6 upon 100. So it will become what? 6 will cancel, log 9 upon 100 it will be. Log 9 upon 100. It will be log 9 upon 100. You can leave the answer as it is, or if you want to simplify it, no. Because he wants to express as a single logarithm. So it is alright. As a single logarithm is log 9 upon 100. We are expressing it as a single logarithm. So log 9 upon 100. Now let us see question number 8. He says, prove this is equal to this. Question number 8 is prove. What is to be proved? He said log 25 to the base 10 plus log 4 to the base 10 is equal to log 25 to the base 5. Now both sides the bases are different. You must keep it in mind. On the right and left hand side I have to the bases 10. On the right hand side I have the base 5. We have to prove them left hand side is equal to right hand side. So let us solve left hand side and right hand side separately, prove them to be equal. What is left hand side? I have log 25 to the base 10 and log 4 to the base 10. Log A plus log B is log A into B. 25 into 4 to the base 10. So it is log 100 to the base 10, which will be equal to 2. Left hand side comes out to be 2, because log 100 to the base 10 will be 2. Now let us see the right hand side. I have right hand side log 25 to the base 5. So 25 can be written as log 5 to the power 2 and 5 here. So it will become 2 log 5 to the base 5. You know, any logarithm of any number to its same base is 1. Log 5 to the base 5 will be 1. 2 into 1, that is by 2. So left hand side is equal to right hand side, so we have been able to prove it. Please remember, log of a number to its own base is always equal to 1. Why? A to the power 1 will be 1 only, nothing else. If it is log 10 to the base 10 is equal to 1, then 10 to the power 1 will be equal to 10 only. So log of a number to its own base is always equal to 1. That is why log 5 to the base 5 is 1. 2 into 1 is 2. Left hand side is equal to right hand side. We are able to prove that left hand side and right hand side are equal. Let us see question number 9. He says if x is equal to 100 to the power a, y is equal to 1000 to the 1, no, it is 10,000. 10,000 to the power b, and z is 10 to the power c. I have x as 100 to the power a, y as 10,000 to the power b, z is 10 to the power c. He says express log 10 under root y upon x to the power 2 z cube in terms of a, b and c. We have to express this in terms of a, b and c. So we have to put the values of y and x and z in terms of whatever is given there. Okay, so let us put the value. Log 10 under root y. That means 10,000 b into half. It is under root, so this we will do that. Upon x square is what? X is this, so x square will be 100 to the power 2a. 100 to the power 2a. And what will be the value of z? Let us put the value of z. It is 10 to the power 3c. 3c. So what will we get from this? Will we be able to get this? b to the power half this. No, I don't think so. We will not be able to get that. What we have to do is we have to convert it to logarithms. We have to convert this into logarithms. That is, x is given as 100 to the power a, so log x will be equal to what? Log 100 to the power a, or a log 100. And a log 100 is what? A into 2 is equal to 2a. So log x is 2a. Then similarly y is given this, so log y will be how much? Log y will be log 10,000 to the power b, or it will be b log 10,000. 10,000 means 4b. It will be 4b. And if I see log z will be c log 10, which will be c. Now let us simplify. This will be what? Log 10 to the power y to the power half log a into b, log a into log b. Let us write log a plus log b log root y minus log x square minus log z to the power 3. 10 into y, log 10 plus log root y, and this is in the denominator, so minus log x square minus log z cube. Log 10 is 1, log y to the power half, so half log y minus 2 log x minus 3 log z. We know what is the value of log y, we know what is the value of log x, we know what is the value of log z. What is log y? Log y is 4b. So 1 plus 1 upon 2 into 4b minus 2 into log x. Log x is 2a minus 3 log z. Log z is how much? C. Log z is C. So it will cancel, 2 2s are 4. So 1 plus 2b minus 4a minus 3c. We have expressed log 10 under root y upon x square z cube in terms of a, b and c. Now let's look at question number 10, which says a is equal to log 2 upon 3, b is log 3 upon 5, c is 2 log under root 5 upon 2. He wants to find the value of a plus b plus c. So let us write down what do we want to find. A plus b plus c. What is the value of a? Is log 2 upon 3. There is no base given, so it means common logarithm to the base 10 plus log 3 upon 5 plus 2 log 5 upon 2 to the power half. It is under root. So let us take this multiple as the power. We will copy down log 2 upon 3 plus log 3 upon 5 because there is no complication here. Only here multiple of 2 is there, so we'll take the 2 up. It will become log 5 upon 2 to the power 2 into 1 upon 2, and that will go also. So you've got simply log a plus log b plus log c. So it will be log a into b into c, that is 2 upon 3 into 3 upon 5 into 5 upon 2. Because this power is also cancelled with each other. So 2 will cancel with 2, 3 will cancel with 3, 5 will cancel with 5. It will come out to be log 1, which is 0. Log 1 is 0. So the value of a plus b plus c is 0. That is the first thing we wanted to find out. What is the value of a plus b plus c? So a plus b plus c is equal to 0. And number 2, we want to find out the value of 5 to the power a plus b plus c. So 5 to the power a plus b plus c. The value of a plus b plus c is 0. So 5 to the power 0 will be 1. So I've got both the values. A plus b plus c is 0 because it came out to be log 1. And 5 to the power a plus b plus c will become 5 to the power 0 because a plus b plus c is 0. 5 to the power any non-zero number risen to power 0 is 1. That is the basic law in indices you've learned. Now let us see question number 11, which is almost of the same kind. X is given as log 12 to the base 10. Log 12 to the base 10. Y is given log 2 to the base 4 into log 9 to the base 10. And Z is given as log 0.4 to the base 10. Here everywhere the base 10 is there. The only problem is with the log 2. Log 2 has got base 4. So we would change that also to the base 10. Here we will apply the formula for changing of the base. For example, I have log 2 to the base 4. So I can write it as log 2 to the base 10 upon log 4 to the base 10. You can change to any base. I prefer to change it to the base 10 because everywhere it goes to the base 10. I could, instead of base 10, I can write a or 5 or 7, anyone. The formula is log 2 upon log 4 to any base you want to convert. I am converting it to base 10 because in my question everything is given in terms of log to the base 10. Now let us see, x is this. Y we have to bother about because log 2, 4 will become log 2 to the base 10 and log 4 to the base 10 into log 9 to the base 10. It means log 2 and 2 log 2. It will become what? Log 2 upon 2 log 2. I'm not writing the base because it is to the base 10. Log 2 will cancel, it will become half log 9, which can be written as log 9 to the power half, which is log 3. So basically you've converted y as log 3 only. This is y. The value of y is converted log 3 to the power to the base 10. Everywhere you can write to the base 10. It is to the base 10 only. So he wants you to calculate, find x minus y minus z. He wants you to find x minus y minus z. Let us substitute the values of x. X is log 12 to the base 10. Y I have calculated as log 3 to the base 10. And z is log 0.4 to the base 10 minus log 4 to the base 10. Log 0.4 to the base 10. Log 0.4 to the base 10. Now it is log a, and these are minus, so they will come in the denominator, division. So it will become log 12 upon 3 into 0.4 to the base 10. I can convert, I will have to remove this decimal. If I remove the decimal, it will become log 12 into 10 upon 3 into 4 to the base 10. Because this decimal will be removed, 10 will come up here. 3 4s are 12, 3 4s are 12. So log 10 to the base 10 is 1. The value of x minus y minus z comes out to be 1. Now he wants you to calculate the value of 7 to the power x minus y minus z. 7 to the power x minus y minus z will be 7 to the power 1, 7. Like in the earlier case, it was coming, I think, 0. Any number risen to the power 0 was 1. So here it is x minus y minus z is coming 1. In the previous question, a plus b plus c was coming as 0. Here x minus y minus z is coming as 1. So the value little change, but the method remains the same. The only thing which you have to learn is here is the changing of the base. We must change it to the common base. We must change it to the common base, and that is how we get the answer. He may not ask you to calculate x minus y minus z, and he might say directly calculate 7 to the power x minus y minus z. For that also you will have to calculate the value of x minus y minus z. That means you have to do complete process here and then apply the value of x minus y minus z. Now let us see question number 12. In question number 12, it's log v plus log 3, log v plus log 3 is equal to log pi plus log 4 plus 3 log r. He wants to calculate the value, find v. That means make v the subject of formula. That means for making v the subject of formula, I'll have to remove all the logs first. For removing the log, what am I supposed to do? Is log a plus log b. This side I can write log a into b. Log a into b. So v into 3 will be equal to, again here, log a plus log b plus log c. Actually it is log 3 r to the power 3. So log pi into 4 into r to the power 3. Because 3 log r means log r to the power 3. Log a is equal to log b. Both sides we can remove the log. So 3v will be equal to 4 pi r cubed, or v is equal to 4 by 3 pi r cube. This is probably the volume of a sphere. This is the volume of a sphere. 4 by 3 pi r cube, I think. Yeah. There's no edge in this, so it is a sphere. So this is the, but you are not going to say whether it is a sphere or cylinder or cone, because only we are interested in finding out the value of v. So for finding out the value of v, first of all we had to remove logarithm. For removing logarithm, we had to combine the term log v plus log 3. Log a plus log b means log a into b. Here log a plus log b plus log c. Please understand, it will be log r to the power 3. 3 log r will be log r to the power 3. You can take the multiple as the power by power law. When you bring the power as multiple, multiple can be taken as power. So log pi into 4 into r cube, log a into b, log this comes out to be, we remove the log from both the sides, 3v will be equal to 4 pi r cube, or v will be 4 upon 3 pi r cube, we get the value of v. Now let us see question number 13. Let's see question number 13, which is, he has given you the value of a square as log x. A square is equal to log x to the base 10. He says b cube is equal to log y to the base 10. And he says a square minus a square upon 2 minus b cube upon 3 is equal to log z to the power 10, to the base 10. And he wants to express z in terms of x and y. Just now log z is given in terms of a square and b cube. From a square and b cube I have to put them in the form of x and y. So a square is already given, so in place of a square I'll write log x to the base 10. This is half log x to the base 10. Half a square. What is the value of a square? Log x to the base 10. And minus 1 upon 3 b cube. What is b cube? Log y to the base 10 is equal to log z to the base 10. Now this power, this multiple will be taken as power. It will become log x to the base 10 to the power half minus log y to the base 10 to the power 1 upon 3 is equal to log z to the base 10. Now log a minus log b. Log a minus log b means log a upon b. So it will become log x to the power half upon y to the power 1 by 3 to the base 10 is equal to log z to the base 10. When we remove log from both the sides, we'll get z equal to under root x and y to the base 3. X to the power half upon y cube root of y. So we have expressed z in terms of x and y. In terms of x and y. That is the method to do it. Now after this, question number 14. In question number 14th I have log x is equal to m plus n and log y is equal to m minus n. Log x is equal to m plus n, log y is equal to m minus n. Express log 10x upon y square in terms of m and n. In terms of m and n. Small n, small n. Log 10x upon y square in terms of m and n. So we will write it as log 10 plus log x minus log y square. Why? Log a into b is log a plus log b, and in the denominator will go as negative. So log 10 plus log x minus 2 log y. We have brought the power as the multiple. Log 10, you know what is the value of log 10. Log m x is m plus n minus 2m minus n. Log y is m minus n. So it will become 1 plus m plus n minus 2m plus 2n. That will be 1 m minus 2m is minus m and plus 3n. So we have expressed log 10x upon y square in terms of m and n.